Figuring out the base demand should be fairly straightforward, but there's a big disconnect that affects design dramatically. So what is that big pitfall we want to avoid? If you plot the amount of water collected in a household against the time needed for each trip to the water point, you will get something similar to this. In the first part, water consumption drops very quickly, from the taps being in the house to 100 meters or so. Then comes a plateau, where a constant amount of water is collected regardless of the distance. From using water almost on the fly as they need it, they transition to deciding to take a certain number of trips. Maybe 1 bucket per person, or maybe just enough to fill the storage they have. In the third part, a new drop occurs. When the distance is increased beyond the threshold, people just take the water their time and strength affords them, which is usually very low. The last phase is a total fail, no benefits from the investment. The middle part is a tricky one. To make it visible, I have come up with a getting ahead loss concept that mocks the hydraulic head loss. The longer the walk, the more social benefits from the project that are lost. Even if the same amount of water is collected, longer walks mean less time to tend your children, to go to school, or to do any other high-value activity. Water has to be close, really close to the user. Planning bigger amounts of water, say 100 liters, is useless if the taps are not close. We would be asking people to haul half a ton of water over great distances, wasting important calories, their time, and ruining their bags. The whole point of a pipe water system is that it does the carrying for people. This disconnect is quite pervasive. As you probably know, water was declared a human right in 2010. This right entitles everyone to sufficient, safe, acceptable, physically accessible, and affordable water. And then you get flyers like this one showcasing this disconnect blatantly. If you do the math, a family with 5 members, a 20-liter bucket, and the tap at 1 kilometer will need to invest 6.25 hours daily. That assuming there's no waiting at the tap. But also, what about not investing more than 3% of the family income in water? What could have been done in those 6.25 hours? What is the opportunity cost? Unless you provide taps right next door, there's no use in planning higher water allowances in accordance to human rights and dignity. It won't be collected. These two pieces, distance and allowance, go hand in hand. So with that out of the way, calculating base demand is simple. We add up demand of different kinds of users and come up with a total figure, as simple as that. The value ranges for each kind of user are easy to find online. For people's allowance, you should have in mind that while you may plan 50 liters per person, that doesn't mean that every person gets that automatically. There will be winners and losers unless there's plenty to go around to avoid power struggles. In a gravity flow system, I like to provide enough water for the demand to be met at all times, which happens around 100 or 120 liters per person. That keeps the pipes full, therefore protected from contamination and constant breakdowns, and allows for a more equitable access to the resource. Lastly, notice that agriculture is usually not included here. With demands of 5 to 10 liters per square meter for the average crop, even a small family vegetable garden can drain huge amounts of water.